Validator. Okay, that's it. Um,
Okay. Confirm if you can see my screen, please. Can you see my screen? Okay, great. Um, so, okay. Like we discussed in our last class, today we were going to just be looking at how to manipulate data frames, and then from there we I'm going to leave you guys with some data that you're going to take back for the break, and then once we resume after the break, then we can look at it all together. Is that okay? So just a recap of some of the things we've been able to do so far. Like I always mention, before you send your data to a machine learning model, you spend 80% of your time cleaning that data, because the truth is you always get data that is not clean. You have data with a lot of errors coming in, a lot of inconsistencies, a lot of duplicates, you have a lot of missing values, and you actually not be able to train a machine learning model with that data if it is having all those things. So the thing is, you spend most of your time trying to clean data, and we have looked at some of the ways, some of the things that we can do to clean data in most of the cases. For example, we looked at a situation whereby you could have duplicates. Let's see from where we started from. We started by looking at, okay, when you get your data, right? When you get your data, the first thing, like we mentioned, was that you have to check your data types. For example, you have to check your data types, and if this kernel, if it's, let me see what. Meaning, okay, great. Thank you for example. Okay, now let's look at this. For example, when you have a file like this, you look at this data, we created a data frame here called data. So this is coming from a dictionary, right? We have the key value pair, like we already know. So if I run this, I'm creating a data frame. For example, let's start from. So when you create a data frame, the first thing that we said is you would want to know what kind of data does each variable get. My network is on and off. It's okay, don't be afraid. There, we're recording the session. So now you want to know which kind of data does each variable hold. For example, we have name, age, and sex, for example. These are variables. And obviously, if we run the D types, which asks you for the different kind of variables that each kind of data each variable is holding, we can get that. Name is an object. Age is an integer. Of course, we know age is an integer because you can see our age of 6.5 is 10 point something years. It's normally going to be an integer. There we have the sex, which is obviously an object. Now, we explained from our last class that it is important to know why each data type is what it is. For example, you want to know why age is an integer, name is an object, or all of that, right? And then when we are able to confirm that, then we could check another one. I think this one we added weight here to have maybe a different kind of different other ones. Let's see what we have here. So we have another this again, and we would have just look at these and validate these as still integers, whatever be the case. Okay, if you have missing values, for example, like from our last class, if you have a missing value for a particular variable, you need to be able to know the kind of data that that variable is holding, because it's going to help you know how to take care of the missing value. For example, we said if your data is of integer type, then you're definitely going to need to either work with the mean or the median. And for you to be able to know whether you're going to use the mean or the median, you need to be able to know the data type you're dealing with, for example, right? And so you can't say if it's an object, you can't feed it like that, because you don't know, you cannot calculate the median or the mean for an object. For example, we cannot calculate if I run this, and let me say I just add a cell here. I say if I say I have to run numpy dot mean for df of what age, for example, is it age? No, I'm not use age because this one's gonna work. Let's say name. Its name. Okay, so let's run this. Let's see. Okay, let's see. Okay, you see, it says could not convert string integer James Mary to a numeric. Why? Because you cannot calculate the mean of an object. Basically, okay. So you see, you can't calculate the mean of a variable that is not of numeric type. So that's why it is important to know the kind of variable that your object is holding. And like the last time, okay, let's copy this code again. And let me change something here, for example. Oh, shoot. Copy. Set up down here. I'm going to paste this code here. And then for some reason, I'm going to do something. Okay, let me just add some 2 cells and then show you something. Let me write a code that calculates the mean or the weight, for example, the mean weight in this data set. So let's say we calculate the mean weight. The mean weight, okay. Let's say we can try. Okay, if we run this, to click this cell, we get a mean weight as 7.5, for example, that's the mean weight. Now let me show you something. I'm going to change something for the weight. So instead of putting this cell here, put it here. So I'm going to change weight, and here I'm going to just change one value.
Zero is the Wi-Fi box.
Madam, can you please mute yourself, please? Thank you.
Never hearing.
Great. So look, I've changed. Just please mute yourself if you are not asking a question. Thank you. Okay, I just changed one value in the age, and it's not more a number. So if I execute this, let's see. Okay, see, if I execute this now, you can't actually tell if this 50 was changed to a string, for example, like you can see here. But let me do t types. And we will df t types, for example, and then we see what we get. Oh, df. Okay, see. Now we see weight. Now weight as an object. Weight now reads as an object, and it reads as an object because simply because of this one change here. Only one of the values was changed from numeric to a non-numeric type. And so just imagine you had this kind of value in 1 million records. They send me 1 million records, and only one of the values was not well entered. You will not be able to know if you don't check the data types. right? And now, if you know that your weight cannot be an object. Weight is supposed to be a number. So therefore, you have to be able to determine your data type. You can clean the data, and therefore, because we were able to calculate the mean weight over here, and what let's see, we calculate over here, what? Now let me calculate the mean weight again with one of those not being an object. I see what we're going to get. You see, we get an error because we cannot calculate the mean weight. Why? Because just one of the values, just one single value, was now not numeric. So I'm just laying the emphasis on why we always need to check the type of data our variable holds. Okay, that's it. That was the first reason why you want to check your data types, because you want to know the kind of operations you can be able to perform on that data set and that particular variable. Okay, that was what we did. One of the things we talked about is we could also convert, of course, like you see here, I'm converting the weight from int to float using the astype function, right? So I could convert the weight to float. You see, and I'm creating a new column here, right? I'm calling this column this, and then just to say we can drop back the old column. Here you see we don't have it again using the df.drop function. We can do away with that column that we initially had here. Now we don't have it here again, right? So just reminding of ourselves of the df.drop, then you remember the df.astype here, which we converted the data type to float, integer, or whatever you want to convert it to. Okay, that's great. Reminding of ourselves of in place. Remember, we said when you want to perform the operation on the same data frame without changing the data frame, you use in place equals to true, of course. Otherwise, you will not be able to get it. You have to assign the old variable to the new outcome to a new variable before you can be able to print it out. Okay. Oh, let me see here. What are we trying to communicate here? Soft. Okay, I think we explicitly created duplicates, if I'm not mistaken. Yeah. Let me see. Okay, yeah. Okay. We also saying that your data can have a lot of duplicates, and of course, it will be very inaccurate for you to do an analysis and see now the results when you were actually dealing with duplicates. And some of the things we can do, we remember tf.info, which gives us information about our data, for example. It tells us the number of non-null. Remember, we said non-null are those values that are not missing. For example, if you do, let me add a cell here. Add a cell above here. If we do tf.shape, remember, if we do tf.shape, it gives us the number of shapes. Is the function? It's not a function. Okay, when we run tf.shape, it gives us a number of rows and the number of columns in the data set, right? How many rows are there? How many columns are there? And then if I run tf.info, now look at the result I get after running an info. The info gives me, says I have 5 non-null, and I know I have 5 rows, meaning that I don't have any missing value in that data. For age, for name, for sex, and for all the columns, for all the variables, right? You see, I have 5 non-null. That means if there was actually the missing value, I would have had maybe 4 something non-nulls, for example. So still remember that tf.info gives you a good amount of information, and it also reiterates all the data types, like name being an object and all of this. And then it also gives you the memory occupation of each variable, as we've discussed in terms of byte. Okay, now, if you now have duplicates, like you can see here, index 0 here is a duplicate as index 1. And so remember, I said the duplicacy has to run across the records. Each variable, Peter 20 M50, Peter 20 M50, for example, right? If you want to do away with those duplicates, we talked about the duplicate function. We talked about the duplicate function. And once we run this, we see that we don't have any duplicate anymore once we run this duplicate function on the data frame. So you have to remember that. We're just reiterating on things we've talked about. Then did I explicitly create? Okay. TF.out here, what we're doing. We just copy it's the same thing. Okay, here we were explicitly creating empty values like missing values. So explicitly created missing values explicitly. And then we check how many records we had. We had 12 records, of course. Now we check. Now look at the value we want to get from no, this is great. Okay, according to this, when we check the shape of our data frame, we have 12 rows and 3 columns. Now, each, for example, says 10 null, meaning that 2 are null, meaning that we have 2 missing values for the each variable. Height says there are 8 null, meaning we have 4 missing values because I'm saying so out of 12, for example, as you can see here. And then the same thing with gender. And so now there is this function called the table which it takes into account the number of missing values, and then you can add the sum function to it to get the total number of small values. And then now we see, for example, here, yeah, that's a confirmation. 4 here out of 12, you have 8 null, that means you have 4 null. And so it gives you an idea of how many missing values are there in your data set. Now, you might now start asking me, why is it that I need to know how many missing values are there, whatever? We remember the rule that we stated that if your missing value percentage, I'm talking about this rule down here, if your missing value percentage for a particular variable is greater than 70, you have to drop that variable. It becomes insignificant in your data set. For example, if you have a variable in your data and it has up to 70% of the data is missing, that means that variable is not good. That variable can't contribute to your data. Well, you can't contribute to your data, so it becomes very important to know whether you are either going to copy or you're going to give it or you're going to fill it. But if it's less than 70, you have to fill it. If it's greater than 70, you have to fill it. So if you can't calculate the number of missing values, then how are you going to determine the missing value percentage? For example, we can see here that we can see 1633, and this is the missing value percentage, right? We calculated that here. So we're just reminding ourselves of what we've done. So we have the rule. And then down here, we were discussing on how to fill. If you now have missing values, for example, and you decide to take care of, how do you take care of them? We say, if your missing values are numeric, you fill with the mean or the median. If your missing values are object type, meaning non-numeric, you fill with the float. It's called the mode. That is the most frequent this thing. But then we didn't just see that. The first thing we said was that domain knowledge is very important. Because for you to fill, you first of all start with domain knowledge. Use your domain knowledge to fill. For example, let me say, for example, I have a data set. Let's say we have a data set for phones, for example. I have a data set for phones. And I know that, so I have, here is ID. So ID, and here is the phone name, phone type, phone, maybe say name of phone, for example. Let's just say name of phone. And here we have the RAM, for example. I'm giving you just an example. Now, this is where domain knowledge becomes very important. If I have phone, for example, let me say I have iPhone, let me say iPhone 15 here, for example, and the RAM is the missing value. Let's say it's a NAND value, for example. That's for the RAM. Is it? And then let me say I have iPhone 14, for example, iPhone 14. And the value is, I don't know what RAM, let me just say 4 GB, for example. Let's say I have iPhone 13, for example, iPhone 13, and it's, let's say 2 GB, for example. Now, if we are following what we are saying accurately, please, I want to confirm if you can hear me. Can you all hear me? Can you all hear me? Are you all following?
Yes, I'm following.
What about I see
So,
just a few persons. Madam Vandaline, are you following?
I'm kind of on and off, but I'm following now.
Okay. How about you, Milton? Is it okay? Milton, is it okay? Right. Let's keep it going. So we were saying that it's important for you to just where domain knowledge becomes important, because if I calculate the mean here, because the RAM is numeric, if I calculate the mean, I'll have, you see that I might have to be taking +2, for example, 4 plus 2 divided by, if I exclude the non, 4 plus 2 divided by 3, for example, right? Or let's say divided by, if I'm calculating just those ones, divided by 2 is going to give me 3. It's going to say 3 gig of RAM. But the question is, so that means I'll fill the RAM of iPhone 15 at 3 gig, the GB, for example. The question is that information correct? That information is not accurate. So before you fill, you need to use domain knowledge first. And unless now you are unable to get some information because the domain knowledge was unable to provide it, now you cannot calculate the mean or the median and fill with it. And so the domain knowledge would have said, the mean and median would have said 3, but the domain knowledge would definitely not be 3. Maybe the iPhone 16 is around 6 gig of RAM, for example. 6 gig of RAM. So that's why I was saying domain knowledge is important for you. When you're filling, you start with your domain knowledge, and then if it's more than, if you can't get that information from domain knowledge, then you can use the mode or the mean or the median, depending on the use case, for example. Okay, now back to what we're saying. Now, another thing we said is that for the whether you want to use the mean or you want to use the median, it depends. It depends on whether you have outliers in your data set or not. When we say outliers, we were saying these are the values that are out of range. Out of range. Out of range means that those extreme values. It could be down or up. And that was when we were able to use I think we plot the box plot. Okay, yeah, for example, we were able to check, oh shit. 7, impossible, yeah. Name is not different. Oh, it's not on the cell. Wait. SNS, okay, it's because I use SN. It's SNS. SNS does plot. So you see, we plot a box plot. And when we don't have outliers, remember I told you how outliers, if there are outliers, you will have some values, definitely you have some plots like this out here. Or maybe you have something like this here, showing you that there are outliers. So if you have outliers, you're going to use the median. I explained to you why the median, because the median is robust to outliers. If you don't have outliers, you use the mean, right? So we do that for all the variables and check. Right? Then we fill. How do we fill? We use the function fill.ne, right? Use the function fill.ne, and that's how we fill. Fill.ne, fill.ne, fill.ne. You see here, I was filling the NE for the age with the median, and if I plot the box plot for the age, for example, if I it's here, plot the box plot for each, for example, let's see I have an outlier. I have an outlier for the age here. So that means if I calculate the mean will be affected by the outliers. So I use the median, right? So that's why I decided to fill the age with the media of age. And then you see this is the box plot for the height. You see height here, we don't have any outlier, so that's why we're using mean. Then the last thing is the mode. We're filling the mode gender, and if you calculate the mode of gender, you will notice that let's see, if we run parent f unique this is the gender. Zero gender but unique. Around unique and assign the unique. Around this. Oh, which one is not counted? Let me concatenate strings. Oh no. On unique what's that? Let me see. Look for the function. Again, plus, which is a function, right? It's not sum. It's not sum values. Again, not flow. Let me run this thing. Let me see that. But let me see that. Can I do the df? Let me see that. Here we go. That I'm going to do. What was the name? Gender. No, I'm using double square bracket, right? So I get it. Okay. Did we feel? So if I run the sum should get male and female.
Not be 20 naira or no 200 naira or so we buy.
Who's battling with 1 naira and 200 naira? Is that you? Say something called unique count. Please let me confirm this function called unique count. Unique. And it's not going to foreign unique. We need to find out, which is still possible, right? Which I can still count. Okay. Long code this one. Simply what we already done. Yeah. Count unique. Let me see. Count unique. Let me check. About count. Okay, yeah. This is how I was getting it. We can use this count of counts. So not here. Sit here. So we can import counter from collections, and then we run that function like against the listing, and then we can just do this. Okay, let me come back. So yeah, remember this counter is uppercase here, counter of PF of what gender. Yeah. Okay, great. This is what I was looking for. Okay, look. When we talk about the mode here, we are talking about the variable with the highest occurrence. Therefore, if you want to actually know what your data set is going to look like, so before I do that, I will run this again. Where did I create this variable? I want to see where I created the variable called TF. No. Okay. Let me run this. I want to do it again. Then I come down here and I do the counter. So you see, before we fill, okay. Before we fill. So let me run counter. You see now. You see. So before you fill, you run the counter. You want to know which one is going to be the mode. Right? And you notice that male is going to be the mode. Male, female, they are just two. There are more males than females. So M is definitely the mode, the number with the highest occurrence. And then you have 4 NAs. That's what counter will give you. So now, after you've checked the number of, your mode now, let's now come and fill this. So you see, we can fill this now, and then we check again, right? See, after we run this, then we come back again and we run this again. You see, males have gone up to 10, but females remain still as 2, then they are not in it. You understand? So that's how it works. We fill with the mode, the number with the highest. So that's how we know that we fill. Okay, let's continue. Yep, and so if I come down again and I something, you see we don't have it again. All has been filled with male. Great. What is it again? Am I forgetting? These are the same concepts that we're just going over and over again. Okay, fine. The next thing we're going to look at after we reach a letter of it is what we call filtering. Filtering is how you subset your data. And this is very applicable. Let's start. So here, let me just run this, and I'm importing pandas as leading number that. And then there is, let me share this code with you because this is not the particular place you can follow along with me for look that out. So I don't want to teach this, I just want you to be happy. But you can also apply your, let's use this one. Who here has heard about Titanic? Zetloni, do you know about Titanic? Did you hear about Titanic, the story of Titanic? How about you, best man? Who has heard about the story of Titanic?
Yes, Titanic ship in the
Mhm.
early 20th century and the data site
Mhm.
survival.
So this data set that we are going to load now is about that ship. So let's see some practical examples of all these things that we'll be talking about. So what I'm going to do is I'm going to load that data set as entry code, so you can just copy and run. So this is the data set. 809. Even without just check the ship, right? Somebody's texting. Okay. So we have just going to f dot shape. So now I'm going so you see, we have 981, 891 rows and 15 columns plus. Yeah. So that is our data set. Please, if you are not following,
Why are you loading
make
it
sure
on
you
Seaborn?
ask. Pardon?
This data set, you choose to load it from Seaborn.
Yes, because it's found in Seaborn.
Seaborn, okay.
It's found in Seaborn. Please, the code is in the chat for those who are following. I left the code in the chat. Don't pick it from there. Okay, great. You go to Seaborn, you will load the Titanic data set, and this is how the data set looks like. Okay, let's proceed. It has 9. Okay, I'll just check the shape. Now, let's see what we're talking about. Look at, before we even go and before we even go ahead, right? Let's check whether there are any df. So I'm just going to run df.info, right? df.info. Then I'm going to run this. Let's see. Okay, I have 891. And for non-null, I see some of them are having non-null. Like you see, this one has null. This one has null. So what I'm going to do is I can run. Let me add another 7 again. Down. I can do df. Well, it's null. It's null. It's a function. And then I can run the sum of its null. So null function again. I run this. We see. Okay. Look at what we have here. This, we are applying what we talked about. Okay. We see most of these things are 0, but each there are 117 values that are missing in each, right? So the question is, how are we going to take care of this? The deck has 688 values that are missing. Embark Town has 2 missing values, and every other thing is fine. So now, before I go ahead, let me just add a few cells. Oh, add the cells from here. Then add a few cells. Let's just understand what this is. Okay, now before I go in, now I want to run the percentage, right? So I'm going to do cf dot is null, which is a function, dot sum, which is not a function, and all of these I'm going to divide this by, right? I'm going to divide this by divided by the total number of values. So I'm going to do tf dot shape. If I do tf dot shape, I'm taking the first one, we've done that, and then we multiply this answer by 100. If you do not understand, please ask your question. The value of shape, and then you give us a total number of records, which is 899. That's what this 0 here stands for. And then we multiply that by 100 gives us 60. So we can run this. Okay, now this is what we get. So this gives me my percentage, right? So I see H has 19% missing values, but look at that. That has more than 70%. So I'm going to drop this, right? So I'll do the F columns so that I always like to do that so that I don't go and copy something that's wrong. So I'm going to do, so definitely I'm going to drop this column. I'm going to drop this column, right? And then I know I'm going to fill this one. Then I know I'm going to fill this one too. Okay. I'm going to fill this one. Okay, now. So let's go ahead. So what am I going to do now? I have to do df dot drop, right? If I say df dot drop, what am I dropping? Say column. The columns what to do. How does it take this thing? It's a list. It's deck. So things are already written so much. Let's go this one. Yeah. And then I say command. Remember, I say this equals to true. Because we are sticking to what we have. And then I return the okay now. Do I have deck again? No run table column. F dot columns. Columns again. I don't have deck again. See, I don't have the deck column again, right? Okay, good. So I'm going to run them. So now let me see. H again. I have to fill H. So I don't know whether H is an object. So what I'm going to do. Tf dot t types. T types. I mean, is this a function? No, it's not running as a function. It's just t types. Okay, now I get this. Let me see. H. It says H is an integer. Yes, obviously. H is a float value, right? It's a float value. So let me see. I want to check if there are any outliers. So I'm going to do SNS dot box plot. SNS dot box plot. How to spell box plot of ZF of what? ZF of what? Is that H? ZF of what? H, right? So when we run this, we plot this. Okay, I see. Ooh, you see, I have outliers. See, that means I cannot use the mean because it's going to affect. So what do I do? Right. So what do I do? I have to, so since it is not going to be like that, so what do I do? I'm going to do, can I just copy it from this other side? I want to type it. I don't want to do it like that. What do I do? And just since it's just one column, let me just say so I'm going to say TF of H, of course. So I'm going to maintain this variable. It's equals to TF of H dot fill MA. And what am I filling MA with? TF of H, and I'm calculating the dot. So this time around, I'm using median, of course, because I can't use the mean. The mean has outliers, so I can't use the mean, of course. That's what I'm saying. So we'll use the function called fill NA. So, and then we return TF. H is supposed to be a variable, sorry. So I can put this like this. Got you. So second. Okay, gotcha. So now that we've done that, we can check this out again. And then I run this again. Oh, this is just simple. Just run this one, then we see what we get. Right. Okay. See now that H does not have any missing value again. Right. Okay. Let's see clock. Embark. I don't know what embark is. Is it gonna be? So let's check from here. What was embark? Embark was an object. Embark was an object, right? Yeah. So what are we gonna do? So what I'm gonna do is I'm just gonna copy this. Yeah, copy first of course. So since I said it's an object, what do? I fill in the mode. Let me add some cells. Okay, so I'm gonna do df of embark is equals to df of embark dot fill ND, and what am I filling the ND with? That's what we're saying. What I fill the ND with, that's what we're saying. We're filling the ND with df of embark dot the mode. That's what we're filling the ND with the mode. And once we do that, we're going to do NTF, and we see this. And so if I run this again, let's see. You see, what is that? It's nothing now. I thought I just ran a few minutes ago. Okay, this is it. So if I run, it's not again. I still get 2. So what field? Oh, there's a problem. Let me check. Oh, I feel something else. I feel embarked down. Choose this one, but I'm getting these from impact. Oh shit. So nothing changed. So it was supposed to be impact, not impact down. So this is I think it's having an ED. It's having an ED here, I think so. Maybe I was running out. So you can so if I run this again, this again. Impact. So I'm down here. I'm going to change. Let me see. Still did not work. Let me feel. Okay. How do you do it? If that thing that is not working. Is it possible? And no. No. This one is not going to give you the thing. But, it's not. I want to know why it's not filling. Okay, wait, let me first of all get it. And do this dot unique. Let me unique here, and then we see the none. Okay. So if I do this, let me see. I want to return the output is data frame, that's why. I want to return I want to return the output as a data frame using masking. That's what I'm interested in. So if you have one values, okay, this is a dot, this NA, then you return it as true. Okay, so what I'm going to do is I'm going to do TF. Okay, no, this NA is NA as a function. Then I'm going to mask this by running TF here, and then this. If I run this, it's shift. Okay, great. It gives me the only values that are running as NA, and I'm wondering why it is not filling it. See, these are the two values that have NA. My question is, why are we filling the OGA and it's not working? Am I typing something wrong? Look. It's not simple. Why it's not work? It is not work. Why? Let me see. Who has an idea why it's not working?
I'm not following you.
But then there's my.
So I've not really been following you.
Am I too fast?
Kind of.
So shit, I'm sorry. Who was following? You should have told me that I was too fast now. Going now. I'm on fire. Right now. Okay, let me explain what is happening. For those that are not following, let me explain what is happening. This one, can you be my talking partner since you are not following? Let me explain to you what is happening. Are you there?
I'm there.
This is what is happening. We have this data frame, right? Data frame, dynamic data frame. This data frame that we imported from that. Yeah. See here?
Yeah.
We loaded the data frame. I want to enter the data. Yeah. Right. Is that clear?
Yeah, I've imported that.
Yeah. Good. Now, when you import that, you want info. df.info, right?
Okay. Yeah.
You notice that this variable has missing values. For example, so if you want, or you can run tf.isNot.sum, right?
Yeah. Yeah.
You notice that it has two missing values.
Yeah.
The same as H. H also had 177 missing values. Right?
Yes.
And then deck, this one, it has 688 missing values. And then every other thing is 000, meaning they don't have any missing values, right? And so I want to know whether I have to drop something and calculate the missing value percentage here, right?
Yeah.
Send me the code. And the missing value percentage. So I'll calculate the missing value percentage. See, where I have for age, I have 19% of my values for age and missing. Make sense?
Yeah.
Now for this other variable called impact, I have 0.2% missing. And then for deck, this one I have 77% values missing. Make sense?
Yes.
Now, having known that, that means from our rule, I have to drop this column, this variable, because it's the missing data percentage is greater than 1.
70.
So this is where I got it. Exactly.
Okay.
This column is supposed to, so if you're supposed to, so now I check again and I don't have that column. See, you know, check this column name. See, okay. I checked it 19 times. I want to check the other types of each of the variables. And I see. I wanted to know each is a fluid value, right? Which normal number in this data, it doesn't make sense that each is a fluid value. We could have used as type to change into the integer, but it's fine. We can still use it like this. Doesn't matter, right? Are you following?
No, I didn't get this part.
I'm talking. Look at the data type of H.
Yeah,
in
float.
that dynamic data set, H is a float.
Yes.
Does it make sense for your
Doesn't make
H
sense.
value to be a float?
No, no. It needs to be an
That
integer.
means, yeah. So that means you can have an H of 30.58. And the meaning of
Yeah,
H
but
being
you
float.
can do that too. Yeah, 30.5, like 30 years and 6 months.
Yeah, which we can. That's what I'm saying. We can accept it like this. Leave it like this. It's fine. That's not the problem here. So now I want to fill my H, right? But I need to know those are there outliers in my H?
Yeah.
Are they outliers? Because like we said, the rule is that if there are outliers, you use the median to fill. If there are no outliers, you use the mean. Is that correct? We said that, right?
Yeah.
Okay, good. So now, this is my plot. I want to check for outliers, and I can clearly see that the outliers they see. Right?
Yeah.
It's clear that they are outliers, right? So I cannot use the mean. So I'm going to use what? The median. Is that clear?
Yeah.
Great. Great. Now, I count down now. Check. So this is where I feel. I use the same variable, the same column, TF of H. Then I'm filling it with the median state. Right?
Yeah.
This is what I'm filling. I'm filling it with the median. And so after I fill that, I return the data frame again. Then I check. I see H now has the missing values. Exactly.
Yeah. Please.
Done with H. I noticed that this other variable, like I told you, embark still has two missing values, right? Exactly. And if I come up here and check the data type of embark, I see some object. Where is it? See, it's an object. Right?
Yeah. Yes.
And if it's an object, that means we have to fill it with what? The mode. Right?
Yeah.
That's what I'm trying to do, but it's not working. Now, as I'm explaining to you, now some things happen to my mind. We have to explicitly calculate them because they might be double. There's a chance that there's no mode. Is it true?
No.
What's the definition of mode?
Mode is the center of a distribution.
Mode. No, mode. Please, that's what you're defining the median. Mode. Is the
Oh,
number with
mode.
the highest the variable with the
Frequency.
highest frequency. It's the
Frequency.
entry with the highest frequency. Right?
Yeah.
Exactly. What if they are like two variables that have the same frequency? Now, are you understanding? Are you understanding why what I'm thinking of right now? So let's explicitly check it. Maybe that's why it's not giving us the explanation. And
Excuse me, Prof.
yes, Mr. Tani.
I don't know if it's from my end or so. I'm struggling to hear. That's why I've been switching devices, but I think it's still happening. I'm struggling to hear you clearly. I don't know if it's from my end or it's from your own side. Please, can you confirm?
I mean, this man, you're hearing me well.
No, I think your audio is not, the quality is below what it used to be today.
Oh, sorry, I'm using something
yeah,
else for
it-
my sound system.
Yeah.
Just manage with me, okay? Tomorrow, next time I'll bring down my headset that I used to play.
Okay.
Is that okay? Please just manage with it. It's possible. Okay. Can we go ahead?
Yeah. This
Sure.
Maybe-
okay.
Yes, best actually.
This rule of thumb for filling missing values when it's integer, you say you should use the median. That is which is the center value of a distribution. Use that for each. And I don't know the median, if this, which is the center value, I don't know if that will properly, I know you say the domain knowledge will suffice, but how do they come about choosing the median for an integer value?
Okay,
when
why are you using the
distribution might
median
not,
and not the mean?
yeah. Yes, not the mean.
I think I explained this in our class in the other class. Okay, for that, for the second question, let me just explain. The thing is that the median is robust to. It's robust to outliers, okay, for example. Yes, let's see, for example. I'm going to say my data, I'm just call data can be, okay, let me just say 2, 4, 6, 8, 10, right? Is that okay? If I do np.median of data, right? You see 6.0. Is that okay? Let me calculate the mean np.mean of data. Around this is 6.0. The mean is 6.0, the median is 6.0. Is that clear? Best man, are you there?
Yes, I will see.
Okay, now look at what. Let me update this variable now. Let me update this variable. I'm going to add 100 to this thing. It's an outlier. See, these values are 20. They are right, but the moment I add 100 is out of range. See, it's 2, 4, 6, 8, 10. Now this value now runs up to 100 automatically, right?
Yeah.
So let me run the mean and the median again, you see. Oh, wait, I did not run this place. See the median? The median has gone up to 7.0, right?
Yeah.
From 6 to 7.0. Let me run the mean. Let me run the mean. You see the mean? The mean has gone up to 21.6.
Yeah.
You understand? So this is clear explanation, and the median is more robust to outliers than the mean. Like, it's not affected by outliers, but the mean is.
I have observations. because you know that if you look at this data, suppose this data are ages for persons in the community, you see that the outlier is just one person, which is just one. While the majority of people, their age lies between 2 and 10. And if you take the mean of the majority of people, which they are, how many number? There are 5 people that have the age between 2 and 10. One person have age at 100. If you go and give an age of 21, you misrepresent this community because there's nobody having the age of 21. So you see that this outlier is actually going to deceive, it's going to miscue, they call it, it's going to miscue the data because it's an outlier. It's not a proper representation of the data because of the number of values that holds true for that outlier is just one, and it's going to miscue the data. So you think people are like 21 years old, why most people are just around the age of 6 or 8. So this 21 is actually the one miscuing it. I think the mean, which is 6, is a better representation of this community than using a median, because this is something we actually look at in statistics.
Let me explain to you. Remember, we are using this concept to fill missing values in your data. For example, if you receive your data, like you're talking about each data, and a majority of less than 10% of your data has missing values, for example, and let's look at the variable like age. Let's look at the variable like age, for example, right?
Yes.
And in that data set, let's say if you want to use your domain knowledge, you cannot be able to tell the age of the 3 participants in that study. Even if you are an expert in the field, maybe you can guess, but not to an accurate value. Unlike the situation for film, where I was talking about the lab, where you can actually go based on the knowledge that specifically the lab is this, for example. For age, you cannot tell, right? You cannot actually say that this person whose age is missing, the age is this. I don't know if you get to that point.
I think you're also not getting the point I'm getting, because I'm looking at the data without bias, without domain knowledge. Like, the data speaks for itself, is a fact. And if, for instance, this is an age, you can see this is an age of young people that falls that younger than adolescents, 10 to 2. And there's an old man that is a grandfather that is 100 years. If this is the data, it's likely that this data deals with data of children, not adults. So if you go and use the median, it will make you look as if it's dealing with adolescents or youths, which is 21. And that is going to be a misrepresentation. So I'm focusing, like, look at the data and work with the data, because the domain knowledge could bring bias into your data, your analysis. And we know that outliers in data are mostly thrown off because they will miscue the data when we try to train models with outliers, because they are just the quantity is little, and they just bring a wide range into the data. So it's in that, because the rule of thumb you gave me, I'm trying to kind of make it how intuitive it is working with data, because the data speaks for itself.
Okay, I'm going back to your question. You asked, why is it that you choose to use the median over the mean? Thanks. That was your question,
Yes,
right? And I was trying to explain to you
Yes,
that
sir.
the reason why you would use median is if your data has outliers, because median will not be outliers will not affect the median. Like you can see, if I'm supposed to fill here, let's assume that I have missing values here, for example. Let's assume that I have a non-value here. This non-value. It will make sense that I fill this non-value with 7 than I fill this non-value with 21. Is that true for us?
Yes. Yes, true.
So that answers your question, right?
Yes.
Because if you have outliers, you use the mean to fill, the median, sorry, to fill. But if you don't have outliers, then you use the mean. That is why before I fill, I have to first of all check it. I have outliers. Look at here. I do have outliers. I can see my box to right. See?
Okay.
These are outliers. Right? So it's clear that this my data has outliers. So I cannot fill the missing values in this data using the mean. It's definitely going to be wrong.
Okay.
For the reason that we just explained below. You understand?
Okay. Yeah.
That's why I used the median. Is that clear?
Okay. Yeah.
But look at this other situation that we showed this way. You remember here, look at everything for age. We had one outlier you can see here, right? See this outlier for age. But then when we did for weight, we did not have any outlier. See, there's no outlier, right? So when we were feeling what we do, feel the age with the median, and we feel the height, but with the mean, because we did not have outliers. Is that clear? And this one has outliers. Make sense?
Yeah.
Awesome. So that's the idea behind this mean median. Okay. Let's go back.
Thank you.
Yeah. So we're trying to understand why we cannot solve this problem here. Right? Maybe I just have a few solutions. What I'm going to do is I'm going to do TF of these variables. Oh, got you. Got you. The reason why it's not finished. Okay. Oh, yeah. So when we run the mode, see, we have to explicitly say that we are using the variables that we get right. Actually, our neighbors. Is it clear that? Let's see what I need. Okay. Now, the next thing. This is where I calculated the mode, right? So you see the mode. The mode is S, right? Right. If I specify the index of the mode, let me say 0, for example, look at what I'm going to get. See, I get S. Right?
Yeah.
But if I just run mode, I explain this is what I get. I get all of this as a series. Right? Some sort of a series. You see? But if I want this S, which is what I want you to feel, I have to explicitly pick 0. See? That's why it wasn't working, because I didn't explicitly see 0 index 1. Is that clear?
Yeah.
Is it clear?
Yeah, using modes from in Python inbuilt.
I think the data frames also do have
not NumPy library.
No, I think data frames do have is it data frame series do have these things. Because what am I saying? So if I include this, let me show you. What did I do the mode thing? Okay, if you look at this, okay, let me run this without the mode function. Okay, let's see the data type. Are you seeing? This is what this is. Okay, if I equate this, let me call this. This. And underscore series. So it's a pandas series. Right? So the series have the function called. For example, I can do this. If you do this, let me show you. If I pick this, if I pick this series, then I paste it here. The moment I put dot, it tab. See, if I take tab, it shows me the different functions that are applicable. If I run down, let me see. Begin to see the different functions that can work for it. Right? You see, this is the field ND that we have been talking about all this while. So if I'm looking for something, you see the mode is here. See that? That's a
Okay.
function. Is that clear? That's not good.
Yeah.
Okay, great. Is there any questions so far? Yeah.
It's what what I was asking. It's the D is a pandas data frame object, but the mathematical actions you're taking with it, the tools you're using it from Python, core Python, like
NumPy?
not NumPy, not NumPy. I
No,
think
no,
NumPy
you're not
might be a
using it
bit
from
robust.
NumPy.
Okay.
No, we didn't use this from NumPy. It's not from NumPy. If it went from NumPy, we would have specified that. Right?
Okay. Yeah.
Okay. Let's continue. I've done a lot of filtering, so I should not spend time filtering again. So you can actually filter, right? You know, we can actually filter like this. And you get only the values where the H is greater than 30 by just running this, right? Or you can, if you want to use NumPy, I use this. NumPy.where get the same results. But then this is not going to give you as a data frame. See that this comes as a series, as an array, sorry, right?
Yeah.
But if you want it as a data frame, you can do it like this. And remember, this concept is called masking. You see, let me show you. I can, let me give some cells here. I can place this here and I take this out. See, I can take this out. See what I get?
Yeah.
If I want the real values that satisfy this condition, go to the mask, right? Going to mask like this, and you see this. Exactly. You see me use this a lot. It's called masking. I used it over here. When I was trying to get, you see, I used it over here. When I was trying to get the exact values that equate to NA, that returns true for NA, is NA. So I do what I mask it. Make sense?
Okay.
Yeah. So now, that's another way of filtering. So basically, you decide to use that. We decide to use where, right? It's all up to you.
Okay.
We use this one. It's up to you. But one will return the data frame, another one will return the series, another one will return the false. It depends on the results you want to get. Okay. Next thing is to, if you want to get how many, just run the sheets. Same thing. It's not wasting our time with that. But if you want to do that, then get for example, let me run this. Gives you this. If I run the line, gives you same information file. This gives you the percentage. Make sense?
Yeah.
Or you're calculating the length, but then I want to by the medication.
Yeah.
And now look at it. So we want to answer that question. How many passengers whose age is greater than 30 to get the percentage of passengers? Here will just be something like skip. Here you have percentage of here. How many passengers who spend fare greater than average spend? So I'm just showing you how you do that. So you can calculate the average mean, right? The average fare. How many passengers who spend their fare? So you calculate the average. Average is the mean. The average is fair. Remember the answer. Parent F columns, right? You see that there's a column called fair, right? So if I run this again, I do F mask F of fair. This I get the data from. If I want to see the average, so if I want to do, I can just run the mean is greater than the mean, right? Because this function becomes the mean, so I can do again. There are a lot of things. Look at the way I did it up here. I can run it like this. Okay, if I to use that, let me put that method. So then I can do this. I can do this one like this. Since I can get data frame for this function, so what I can do is I can do the f of f. So I'm using masking here. I'm just masking directly. So don't ask me what I'm doing. I'm just masking directly. So it's fair here. And then now once I do that, I get greater than CF of fair is fair again. Now look at what is happening.
You should have wrapped the other tuple now, the 30.
Let's go gradually before we go and make a mistake again. So let me do the f of fair, right, greater than the mean, and the mean is the f fair, right? F fair, and this time around dot mean, right? So since this one term is going, so we're gonna grab this one. You get it? Right?
Yeah.
And then we now can mask all of this one. Then we do, that's where we mask. And then if we run this, we get a data frame grade. So if you want dot shape, see, this is it. You get it? So you can see that the same number of value we have for length, we have 211 here. Make sense?
Yeah. When you take out the shape, it's
If I take out the shape, I get a data frame.
that shows what is greater than the mean.
Mm.
Is that what it shows? Unfair? the
Yeah.
I mean.
Yes.
Yeah.
So for
If you
example,
take out the masking, then it gives a boolean.
it gives you true false.
Yeah, a boolean. Okay.
If I do this, it's gonna give me a series. True false,
Series.
true false, true false, true false. See?
Yeah, that's a boolean. Yeah.
Yeah.
So you okay.
Make sense? Mhm.
And you can sort it as well. If you want to sort the answer, is it possible?
You can sort, yeah, you can apply sort
Yeah,
particular
sort in
variable. For example, we can do
on the
how do you want us
masking.
to sort it? You want to sort it and mask it. So what
Top
I'm going to
down.
do is
Yeah, where is mask? Yeah.
I can use sorted. I prefer to use sorted.
Okay.
Sorted of what am I sorting? So I'm using TF one fair,
Copy
right?
and paste.
F fair. So I can just copy this and paste.
So we copy the masked version.
Yes, just copy this. Right.
I don't think you can sort boolean. Can you?
Of masking.
No, I was thinking you mask before you sort. Like, I don't think that will go through.
Now you mask before you sort.
Yeah,
Like
the
this.
DF. Yeah.
Let me try this.
Inside the sort. Yeah, I think because an object, let it be a data frame or pandas object of data frame type. I think that's one maybe. Okay. More attributes. True. Hmm.
So I wanted to do this way to look at something. Let me get it like this and get a new frame. Let me try this and see what I get. Let me see where the error is coming from. Fair.b.
Yeah, one
It's not
square
copied
bracket.
somewhere.
It's
Yeah.
there. Yeah,
Yes.
square bracket.
This one got. Yes, this one's. This. Okay. That's not attribute me.
Oh, list objects. So I don't think you can sort it out.
This on the column. Let me see. Oh yeah, you can sort this on the column, right? Sorted. No, I do. What am I sorting? VF. Let me just sort this on fair, for example. Exactly.
All right.
Let's sort this. Fair. And again, this string. Yeah, sorts. Right. Sorts these.
You can sort it, sort after matrix.
Sort based on what? Based on the particular column. Okay, great. There's some more things that I want to show you before the time goes off again. I know we've not talked about that. So we can do unique. I've shown you unique equals to, for example, if I run 6, so you want to figure out what you remain, you can run unique. You want to know unique equals to females, for example, equal. That's what, how many passengers whose age is greater than 8 females. So now you do this, then choose subset of filter that fetch the big as you see. These are just easy things. Okay, this is what I'm interested in. I don't know, showing people log. Have we treated log and ilog? Have we done that?
Lock?
Log, okay. The way you just asked is clear that was not that. Okay, let me show you something. Okay, I'm gonna return the F, right? Return the F. Okay, now I can pick. And if I want to select a particular row and a particular column, for example, I can say, look at this presentation. I can say CF dot. Let me start with log. I think it means ilog first. Because if I do ilog, look at, let me show you. I'm going to do 0 and let me just use 1. See, I'm making this 3. What have I done? I have indexed row 0. Please pay close attention. I have indexed row column 1 based on this index number. This is column 0, this is column 1. That's why I have 3. Like what we're doing with NumPy. Are you following?
Yeah.
So if I want to, for example, if I want to pick this 7.55, for example. Are you getting me?
Yes.
I'll do CF dot ilog. Are you following?
Yeah.
Ilog, what am I doing? What is
Index
the row
log.
number 890? Are you following? And then
Okay.
this column is what column now? What column index? So this is 0, 1, 2, 3, 4, 5, 6. Okay, that's column 6. So if I run this, I get this 7.75. Is it clear?
Oh,
This is
okay.
log, right?
Index.
And
Okay,
now,
index
there is another.
location.
This
Start
is
up index
yes,
location.
index location. Yes.
Okay.
There's another one called log. Now this one takes, it takes you can, for this one I can do CF. This is when you don't know the index location. You use the location. Now I can do the same thing for this one. Let me take for example, let me use
The
890
reverse.
for example.
Okay.
But this time around I'm going to use this. See, what was the column name? Fair. Right?
Yeah.
You see,
Okay.
right?
Okay. Yeah.
Is that okay?
Yeah.
I can get the sex of the person who paid this fare, for example. I can get TF dot ilog. Now this is going to be a little challenging because if I want to do it, if I do the sex, you just pick everything. Maybe I can try to do it. Let me get the sex of all. Let me do something. I want to try something. Okay. No. I don't. I'm going to do that. So let me do 6. Are you following? 1.
Yeah.
Okay. One is very fake. Okay, see, I'm going to do this like mask this. I want to see something. See why 6. How did I spell the 6?
You are getting double indexing. That's, I think, because I'm repeating it. Could it be? Set and fair at the same time. Small.
Can I do this?
What's that? Is the index?
So now I want to explain what is happening here. You use log and then you specify, you pass the column name. You understand?
Yeah.
And then you pass your
Yes.
index, the index. For example, if I pass any index here, let me say 50, for example, and do
Yeah.
comma,
Comma.
the column
Yeah.
name or negative value.
Give it
You
the index.
understand? Yes.
Yes.
So when you use ilog, index, ilog will go with index and index. But when you use log, you can actually pass text. Is
Yes.
that clear?
One is index location. One is the location in data frame. I will get the index.
Yes.
It's the reverse. They are inverse of each other.
Great. So that's one of the things I wanted to show you today, which is really great. All of this we've done. Mode value count. This is the function I was looking for. Oh shit. See the function I was looking for? Value count. Let me run this. Here's the function I was looking for. It's a function called value count, and it applies to oh yeah, now I see why. It's for data frames. It's not for oh now I see why. I was trying to do this for something before I used Outlook. I was looking for this function, right? I say I get it, right? But then this must be a data frame. I hope you know that this is a data frame. Okay, for example, if I do this, it's not going to work. See, if I kill this, if I do this, for example, it's not going to work. See, it's not going to work. Oh, it still works even with this. It still works for a data series. So if it works, that means if I tap here, I'm going to see value counts. See. Yes, it's there. Great. So this is the function this is the function I was looking for the other time before I went to the topic count. Okay, back to this, please. What is it here again that I want to come? Oh, group by. Very important. So now let's see. We can where did I actually use group by? Okay, now we can do group by. Okay, for example, average face spent by males and females, for example, right? So this is males. For example, you get the mean spent by males, and then you get sex. Group by males. Use the function group by. See, group by then specify males. So now look at what I'm doing here. I'm saying G is equal to TF of group by, and I'm doing that by 6. And I'm doing G dot get underscore group equal of names. So we can do anything. Okay, let me see. Let me see. What are some of the good things we can do here? Sex was a good option. In fact, false. Okay, yeah, and group by survivor is one. So what we can do is here. Let me see. Let me just see data 1 is equals to TF dot group by. What am I grouping by? What I want to group by that variable was for our life.
Group by alone.
I want to group by alone. I want to see, maybe I want to see those who survive who died, for example.
Okay,
Right?
alive.
Yeah.
Yeah.
So if I
Survival.
return data 1, for example, okay, now
Data dot
if I
get
want
group.
this, so it's a generic data frame, so it doesn't return data 1. Okay, now let me see. If I want to get the, no, this is, if I want to do this, okay. Still the same thing. So now I can do see data 1 dot get, right? Get underscore group. That's the definition. You're getting underscore group. What group are you getting, right? And I'm getting the group. Say let's see the group that survive, right? And let's say yes. Then if I run this, see, 142% survive. You understand?
Yeah.
That's how the group by functions work. There's another one called aggregate. Let's aggregate. And I do anything on it here. Okay. Did aggregate here. So, and then there's h dot aggregate mean. Okay, now let me run this. See, look at what is happening. Now, aggregate is a function. Aggregate can take anything. It can take the mean, it can take the you can take the mean is, for example, that's the average. You can take the sum. You understand? For example,
Yeah.
let's see. If I want to run okay, let me see the aggregates age of the people who survived, for example, right? So let me come up here. What's that place where we get alive and survive? Okay, this is it. So now let me add a few cells here. So now, see, if I do this, maybe I already have data 1, right? If I take data 1 dot like this. Let me just say maybe I just run. Let me just say TF dot group by then grouping by, we said it's alive, right?
Yeah.
Then what are we
Yeah.
grouping by alive? Then we're getting the, let's get the, yes, let's, each of those who survive, then we are getting the aggregate is AGJ. Now, how do we get it? Are we getting the mean age of the sum, right? Are you getting what I'm
Yeah.
saying? So you can calculate, like, for example, when you do where is that place? You have to, so instead of writing mean here like this, let me do shift up here first of all. I'll show you. If I do shift up, okay, doesn't give me that that option. I'm looking at the I'm looking at the lost my thoughts. Okay, the aggregate each of all the people who survived, right? Maybe for example, how many people died, how many people did not die in terms of the age, the sum of the age of the people who died and the sum of the age of the people who did not die. And if you look at the way I think this one down here, basically, you'll notice that first of all, first of all, I have to what is that place? And then I do the let me just pass this up here, for example. Say so. And I'm going to run this. Oh, it is the sum of those who did not die. So 16,482, and the sum of those who died, right? That's the I. So it doesn't even make sense to say that the sum of each, right? It doesn't make sense to say the sum of each. Let's look at the mean age, which is going to give us the average age. So it can give us better example. So we notice that mostly people who were around the ages of 30 did not die, and then died. Then the people who survived were mostly around the age of 28, something like that. I don't know if you get the idea.
Yeah.
That's how this aggregate function works. So it can be anything. It's just that this data too is funny. So that's how you can use group by and aggregate. I don't know if, unless you practice and then you have an equation, and then you can actually then maybe ask me a specific question. Otherwise, that's going to be it for this particular thing. Let me look what I've missed. So I've shown you group by, I've shown you aggregate. So you can even calculate the mean, the sum. Like you see what I'm doing here, I do the mean and the sum in one function, right? And you can do like this. You can do the mean of the age. Okay, for example, we can know for the people who died, for example, right? We can do their mean age. So we can do it like this. So I can do the mean age and how and the sum of how much all those who died paid. For example, I'm going to do fair. Get the sum of the fair that those who died paid. So if I run this,
That's a semicolon. I mean colon, no. Is it a dictionary? No, it's a dictionary. You have to wrap it in a dictionary.
Yes.
Maybe because you use alive. Maybe alive it doesn't have integer values. So
Yes,
it probably is a
that's the thing.
category used. Yeah.
You're supposed to use integer value. That's why it's not supported. Then, but even if it's not supported, I'm moving by things and I'm using.
Right.
I'm say but here I became the H, and that's why. Yeah, you see. It's because here I was passing only the H, but I was not passing this FA without expecting to get the FA or something. So that's it. Look at it. That's the output. So you can now see that the mean age of those who did not die, who died, and then the total sum of those who died with that ship. This is the amount of money those that died paid. You see, right?
Yeah.
Yeah. So that's how sweet this can be. Anyways,
Yeah.
I'm going to give you people this as an assignment so that you can do right. So you have to do this as an assignment. Which man? So you have to answer these questions. Right.
I think you have to share this page with us.
Yes, I'll have to share this page with you so that you answer these questions. You have to answer all of these questions. Watch this recording, and then at the end, answer all these questions before our next class. I'll share this page with you people right now. So let me just share it now.
Prof.
Forget.
Prof,
Yes, Mr. Tony.
please, what about
Yes.
the other five? I'm not even the
Let
entire
me share
seven.
this. Let me come back to this one. Let me know, but please let me check your filtering. Is that okay? This is called filtering, right? Let me shut this down. Download this. Champions badge. So now this tag champions badge. This is your badge. So you have to upload this here. It's 5. New file. Yeah. So, so this is the file that I've uploaded. Let me. So what I'm going to do for the other ones is that I'm just going to. You know what I'm going to do? I'm just going to come back here. Let me shut down one of these. You know what I'm going to have here. Let me see. I'm just going to. problem. Yeah. Space. Cannot download a good folder. Sure. Show me. He's trying to show me sense. And new folder upload and then why is it not uploading now? Okay. So you see, it's uploading all my files. So please don't ask me again. Is that okay? Is that okay?
Until we get it now.
It's gonna take some time. Yeah, you see CAV, right? Gonna take some time. So are there any questions as far as what we've done today is concerned? Any questions? Okay. We have no questions then. I will only see these faces after Christmas. Please do my assignment again. When we meet again, this is how we are going to renew ourselves. This is how you are going to remind me, people teach me, and then before we enter plotting. Once we finish visualization, that's plotting map of the symbol, then we start doing some machine learning. Is that okay?
All right.
Please do my assignment for this same data set, this Titanic data set. Some description. Is that clear?
I'm keeping this. Okay.
I'm open to questions during the break. If people are the ones going for break, no, I'm not going for break. So we can text my WhatsApp. Okay. Let me stop the recording.